So if you notice, I tried to give you some questions that had multiple studies or multiple experiments so you could practice getting better with those types. So I want to give you a little advice on maybe how to approach these. Most people say don't read the passages, and I tend to agree. However, you might want to actually just look, if you're looking at a problem like this, for example, and you see they got a study 1, then they have a study 2, you might want to go ahead and just read the first couple sentences of study 2 just to find the main difference between the two studies. So you can see right here, study 2, the sediment in the other core from each of the 10 locations was sampled at the top. So what that's going to tell you is, they did something else to the other core, and you may not need to look at that right now. So let's just go to the question that you missed here. Okay, according to the results of study 2, there was no calcite found at which of the following depths? Okay, so I find study 2, right here we go, and we're looking for a percent mass of 0 for the calcite. Okay. Okay, so which depth had no calcite? Okay, so I'm looking at this. I've got a 0% mass here, so it looks like I have two depths, 7 as well as the 5. Okay, so as far as that's going to go, it looks like we have 5 is the one option there, which is why B. Alright, then 33. Consider the average percent mass of argonite at a depth of 10 centimeters as showed in figure 3. On average, the mass in grams of argonite present in a 50-gram sample of sediment taken from that depth would be closest to which of the following? Okay, so let's take a look at that graph again. Argonite, 10 centimeters. The argonite's going to be the dotted line, so I'm going to come over, I intersect right here, and if I come down, you're talking about 10% mass, okay? About 10% mass. So they were giving you a 50-gram sample, so what would be 10% of that 50 grams? That's how they're getting that 5-gram answer there. Okay, and then here we go with this next experiment. And again, you're dealing with experiment 1 and experiment 2. So again, no need to really read the passage. Just go to experiment 2 and let's just see if they mention what the difference is right off the bat. Okay, so it's going to be about synergism, and they give you a quick definition there, and then they tell you right here, okay, experiment 1 is repeated, except that different pairs of bacterial species were added. Okay, so you can, without even looking over there, you can probably say, okay, they used pairs here, maybe they just tested them independently here, and that was the actual case. They looked at individual species on the first experiment, but then they looked at them in pairs on experiment 2. Okay, so the question here we're looking at the evidence from experiments 1 and 2 that species C and D acted synergistically in experiment 2. Okay, so let's take a look. They're going to sort of require you to use both experiments. Okay, so let's take a look at this first table comparing C and D. Okay, so sucrose, species C was able to produce an acidic environment as well as carbon dioxide. With the lactose as the medium, it was not able to produce an acidic environment or the CO2. Species D, that was positive acid, negative CO2, positive acid, negative CO2. Okay, so the one thing that stands out here is when they were independent, neither one could produce CO2 when given lactose as the nutrient. Okay, so let's take a look here. Alright, what's the evidence from experiments 1 and 2 that species C and D acted synergistically in experiment 2? Okay, so now we've looked at table 1. Let's go back and look at table 2. When I had C and D together, they were positive for every single indicator regardless of the sugar type. Okay, but again, remember from table 1, neither C or D was able to produce carbon dioxide from that lactose medium. So what that's going to tell me is when they are together, when C and D are together, they are going to act synergistically and be able to produce the carbon dioxide when given that lactose broth. Okay, so let's see, let's take a look at C. No CO2 was produced when each species was alone. Okay, so the problem there is C did produce CO2, but D did not. Okay, no acid was produced when each species was alone in the lactose. In the lactose, one of them did produce the acid, so that would make B right as well. And then A, no acid was produced when each species was alone in the sucrose. And that's just not true because both of these were able to produce an acid when given the sucrose. Okay, so again, no CO2 was produced when independent, but when you put them together synergistically, they were able to they were able to sort of fuel each other's metabolic reactions to produce that CO2 when given lactose.